The magnetic flux produced in the unshaded portion of the electromagnet is minuscule too. The shaded portion of the flux pi 1 is 40 to 50 degree lagging with the unshaded portion of the flux pi 2. The two alternating fluxes pi 1 and pi 2 induce two voltages V1 and V2 on the disk. These two induced voltages V1 and V2 create eddy currents I1 and I2 on the disk. These two eddy currents produce a deflecting torque on the disk. This deflecting torque is directly proportional to the square of the current to be measured, that is Td alpha I square. The disk rotates depending on the residual torque between deflecting torque and the spring action and attains a balanced position. This position is graduated against the actual pointer reading of the parameter. When the disk rotates, it cuts the magnetic field generated by the permanent damping magnet. Hence, eddy current is induced in the disk, which interacts with field of the damping magnet and produces a torque in the opposite direction to deflecting torque. Now you are going to see the phasor diagram of shaded pole type induction instrument. The vectorial sum of two magnetic fluxes pi 1 and pi 2 gives the resultant magnetic flux pi. These two fluxes pi 1 and pi 2 induce the voltages V1 and V2, which are in 90 degree phase shift with the fluxes pi 1 and pi 2 respectively. The two voltages V1 and V2 induce the eddy currents I1 and I2. Each eddy current is lagging by an angle alpha with the induced voltages. Thus, you have learnt about the construction, working and phasor diagram of a shaded pole type induction instrument.